Hello, my AB Calculus class. We are looking at question 2018, number 4. It's a table question. There are several types of table questions, but this is the one where they give you some data and ask you to move on from there. Anyways, so let's start with part A. Part A, they're asking you to estimate h prime 6. So we want to know, what is h prime 6 about? And we've seen this question so many times with table questions. Hopefully you're used to it by now. Okay? Let's say the graph of h, I'm just making it up, but say the graph of h looks something like this. If somebody wanted you to find the real h prime 6, the actual h prime 6, that's the slope of the tangent line. Okay? H prime 6 means what's the slope of the tangent line at 6. And if we had an equation, we would take the derivative, we'd plug in 6. We don't have a derivative. So how do we estimate h prime 6? How do we estimate the slope of a tangent line? Remember, slope of a tangent line is the slope through one point. We're going to estimate it by finding old school slope, estimating slope using 2 points. So instead, we can estimate h prime 6 by taking two ordered pairs and find, well, that's the worst line. But anyways, if you took two ordered pairs and found the slope through those two, that's how you're going to estimate it. So instead of finding the slope of the tangent line, the slope through one point, you're going to use 2 points and find basically old school slope. And here we need to be finding the slope using numbers around 6. Now the biggest mistake that I get is people subtract the wrong things on top. Remember, it's just slope, y2 minus y1 over x2 minus x1. T, you see h of t, normally you'd see like f of x. So x is like t in this problem. So these are the x's, and these are like the y's. So when I subtract the y's on top, make sure you're using this. So I'm going from 6, so these two ordered pairs are nearby, so I'm going to subtract my y's on top, 11 and 6, and then 7 and 5 on the bottom. There is no reason at all to simplify this. Don't simplify. You're done. If you want to simplify, sure, you get 5 over 2, great, but you don't need to simplify. And then the second thing they want is, they want interpret the meaning of this with the correct units. Let's start with the correct units. What did we subtract on top? 11 and 6. 11 and 6 are meters, so meters are on top. And then we subtracted 7 and 5, which are years. So the units are meters per year. So if I simplify this, I could use 5 over 2 or 2.5 meters per year, but I'm not going to. So let's look at the type in the context of the question. The height of the tree is given by the twice differentiable equation. So this is just the height of the tree in years. So at time equals 6, all right, or when the tree is 6 years old, you got to talk about time. The height of the tree is, and now I want some word if my answer is positive or negative. Now here you can see this is a positive. The only reason you might want to simplify it is to see if it's positive or negative. But I can see it's positive, so I'm going to use a word for positive, increasing. If it was a negative, it'd be decreasing. So the height of the tree is increasing at a rate of, I can just keep this right here. Now you could simplify it again to 5 over 2, and then again units, meters per year. So at time equals 6, the height of the tree is increasing at approximately increasing at a rate of this many meters per year. And that is part A. Okay. All right, part B. They want to know, can we prove at some time c, h prime c equals 2 for some c on the interval 2 to 10. Now, the moment you see a c in the problem, it's either intermediate value theorem or mean value theorem. It cannot be intermediate value theorem because intermediate value theorem would work like this. Look at this here, 2, 3, 4, 5, 6, 7. If we took the ordered pairs, at 2 it's at 1.5, at 3 it's at 2, at 5 it's at 6, at 7 it's at 11, at 15 it's at 10. The way the intermediate value theorem would work is, since this is the graph of height, we could prove, that if right now the height's at 1.5 and later on up here the height's at 15, it could prove things like h of c would have to hit a height of, and pick any number in between, 10. You know, it'd have to hit a height of 10 because 10 is between these two, and in fact, 10 is between those two, so it'd have to hit a height of 10 between time 5 and time 7. That's what the intermediate value theorem can do. The intermediate value theorem talks about the graph you're looking about. If this is the table for h of t, it can prove things about h of t. But we don't want to prove things about h of t, we want to prove things about its derivative, h prime c. Okay, so mean value theorem normally looks like this. F prime c will be f of b minus f of a over b minus a. All right, that is the mean value theorem, and it works if the function is continuous and differentiable. So I could quickly say that they tell me it's a twice differentiable function. So you could say h of t is differentiable, so the mean value theorem applies. Get that out of the way, and then you try to use the mean value theorem. And again, the mean value theorem, if you were to see a picture of it, if I have some graph like this, the mean value theorem guarantees that if it's a differentiable, smooth, continuous function, if I find these sloped through the endpoints, that's old school slope, then for some c between a and b, the slope of the tangent line has the same slope as the slope through the endpoints. And then the only difference in this question is instead of f, it's h. So h prime c would have to be h of a, the height at some time a, h of b minus h of a over b minus a. Okay. So the first thing I would try with this mean value theorem is I'd say, let me just look at these endpoints. You know, at time 2, it's at 1.5, and at time 10, it's over here at 15. And this is not going to work, but this is where I immediately would go. Every single other time we've done mean value theorem on the AP exam, if they say from this to this, these are the ordered pairs we're using. And it would say, h prime c has to equal this minus this. 15 minus 1.5 over 10 minus 2. But if you do this, you get 13.5 over 8. And 13.5 over 8 is not 2. So the mean value theorem guarantees that we'll have a slope of this. It does not guarantee we'll have a slope of 2 if I use these ordered pairs. Now here comes the crazy part. Well, if these two ordered pairs don't work, which ones are going to work? Do I use these two? Or these two, 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 or these two? I now have like 10 options for slope. I'm just going to quickly look at it and see if I can find slope really quick. Subtract the numbers on the top and the bottom, and I already know the answer. I know it's cheating. But look at this. If you subtract the y's on top, 6 minus 2 is 4. If you subtract these on the bottom, 5 minus 3 is 2. So that's a 4 over 2. 4 over 2 is 2. And it's crazy, because who's going to look for that? I mean, you might see 11 and 6. That's 5 over 2. We already did 5 over 2 earlier. It didn't work. This is 4. If you subtract those, 4 over 3. So, anyways, since h is differentiable, the MVT applies, and we're guaranteed h prime c would have to equal, and again, I'm going to be using these ordered pairs here. I'm using the ordered pair of 3, 2 and 5, 6, or in other words, h of 3 is 2, h of 5 is 6, and I get 6 minus 2 over 5 minus 3, so 4 over 2 is 2. Crazy question. I understand it's a crazy question. You might not get all points on the AP exam. There's like literally 8 people, like in the whole world, to get all the points on the AP exam. So sometimes some questions are just a little bit off. If you thought mean value theorem, you were right, and then all of a sudden it didn't work, and that's why you had to use different ordered pairs in the endpoints. How much fun. Okay. So now let's go to part C. And C, they ask you to use a trapezoidal sum with 4 subintervals to approximate the average height. Now, I'm giving this year's people, coronavirus people, average height can't be on your AP exam because average height would be 1 over b minus a, integral from a to b of height. However, people in the future are going to be watching this. So let's look at this for what it can be used. They want to know the average height. This is the formula for the average value of a function. All right, on the interval of it says 2 to 10. So it's 1 over 10 minus 2, integral from 2 to 10, h of t dt. Okay, now 1 over 10 minus 2 is 8. So we get 1 over 8 times, and this is what you have to remember. When you use trapezoidal, or right Riemann sums, or left-hand Riemann sums, or even midpoint, all four of those are used to find or estimate the area underneath the curve. So, not using this whole thing, it's only used for this part, the area underneath the curve. Okay? So, we want to know what's the area underneath the curve, and we're going to estimate the area underneath the curve using this and a trapezoid. Remember the trapezoid formula? 1/2 height, base 1 plus base 2. And we're going to have 1, 2, 3, 4 trapezoids. So 1/2 height, base 1 plus base 2. 1/2 height, base 1 plus base 2. 1/2 height, base 1 plus base 2. And finally 1/2 height, base 1 plus base 2. Okay. So the first height, how far are these apart? 1. And then these are my base 1 and base 2. So 1.5 and 2. My next trapezoid, 3 and 5, that's a distance of 2. And my base 1 and base 2 are the 2 and the 6. And then the height is 2, and I use 6 and 11. So height is 2 and 6 and 11. And lastly, a height of 3 and 11 and 15. So a height of 3 and 11 and 15, and I'm done. Notice we have the 1/8 in front because it's part of the average value formula. So 1/8 of, and then all this stuff is the trapezoid. And that's your answer. There's no way in the world you will simplify it. Don't do it. Oh, by the way, wow, if you're following along looking for that, it's C. Okay, and now it's gone. Alright, last but not least, we have part D. Part D is miserable, and it's worth 3 points. So the height of the tree can also be modeled by the function g of x equals 100x 1 plus x, where x is the diameter of the base of the tree, when the tree is 50 meters tall. Wow. So when h of t, when the tree is 50 meters tall, and again, crazy question, the diameter of the base of the tree is increasing, so the diameter of the base of the tree is increasing at a rate of blah, 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 blah. According to the model, what is the rate of change of the height of the tree with respect to time? Okay. Wow. Crazy question. So the diameter of the base of the tree is increasing at a rate of. Unbelievable. Okay. Well, anyways, let's go look at the question. This is g of x. Again, g of x is the diameter of the base of the tree. We want to know the rate that this is changing, meaning we want the derivative. But it's a sneaky derivative. We want the derivative with respect to time. If you read the question, I want you to underline the word with respect to time. With respect to time means this is a related rate. Just really quickly, if someone said, hey, the area of a circle is pi r squared, and they wanted the derivative, well, normally you just say the 2 goes to the front, 2 pi r is the derivative. But if they said with respect to time, you would say not a prime, dA dt, everything gets a chain, and then the derivative here would be 2 pi r, and you'd get the chain dr dt. with respect to time means related rates means everything gets changed. So when you take the derivative of r, you get dr dt. Take the derivative of a, you get dA dt. In this question, when we take the derivative of x, we're going to get dx dt. All right, so let's go plug stuff in. We need the derivative, so we're doing quotient rule. And again, it's related rates. Keep that in mind. So it's low. D high. The derivative of 100, x is 100, but we need the chain dx dt. By the way, when we get to dx dt later on, what in the world is dx dt? In this problem, dx dt is that 0.03 number they give us. Okay, so low d high minus high d low. Well, the derivative of the low is simply 1, but we need that chain dx dt, and then all over low. Okay, and then you get excited. You're like, oh, x is 50. dx dt is 0.03. But no, you see x is not 50. So sorry, it's a crazy question. What is x? X is the diameter of the base of the tree. What is 50? 50 is the height. Okay? So, when I say height, in this problem, height is actually g of x. G of x is the height. It's so crazy. So, you actually have to go way back here and say this g of x is the height. When this is 50, what's x? So, you actually have to put a 50 here and ask what value of x will make the height this. Hard question? Yes. And let me do a little cross multiplying. If I cross multiply this, I get 50 plus 50x. So I multiply that to the other side. And then I'm going to move my x's to the other side. So if I subtract the 50x, 100 minus 50 is 50x. If I divide, I get x is 1. And again, I already said dx dt is 0.03. Yikes. So now I finished the question. G prime of, now I know x is 1. So it's 1 plus, that x turns into a 1. We have 100. We have dx dt is 0.03. Again, x is a 1. dx dt is 0.03. And on the bottom, again, x is a 1. And I know this problem looks ugly, and they even left it different online. This is how I would leave it, okay? Different ways of doing this one, but leave it here. If you were to simplify it, which you're not going to, you'd get 3/4, just like they have online. Crazy question. You don't get all points sometimes, and that's okay. Thanks for watching. Bye.